When given a factoring problem, the first thing you always do is look for a common factor. Now we're going to discuss the ladder method. This is not in your textbook, but it is on YouTube with many, many examples. But when you do go on YouTube to look at this, only look for the ones that say common factor. They also have an LCM and other things to do with ladder method. So make sure you zero in only on the greatest common factor method. All right, we come over here and we take a look first to see, do we have a common factor? I always look at the variables first. So I see an x squared, and I see over here an x, and I'm missing a variable in the last term. So therefore, there is not a variable in every term, so there's not common. Then I go overhead and look at all my coefficients. Now, you may see right away that your greatest common factor is 10, but then you may not. So first thing I do is I look for, is it divisible possibly by 2? Are all the numbers even? By 10, by 5? Let's just say we're going to go ahead and see that they're all even numbers. So I'm going to write every single coefficient. Leave a little space between them so you know that they're separate. I'm going to do an L here, big L, for a ladder. And now I know they're all even, so I'm going to put a 2 here. 2 into 50 is 25. 2 into the 30 is 15. And 2 into 10 is 5. And now I continue looking. Can I divide anything evenly here? Can I take out a factor? Well, they each end in 5, so obviously I can take out a 5. 5 into 25 is 5. 5 into 15 is 3. These are easy numbers. 5 into 5 is 1. Well, I have a 1, 3, and a 5. There's nothing common about those numbers. So I am done. So I go ahead and I take these two numbers, 2 times 5. I multiply them, and I get 10. And look at that. That's my GCF, my greatest common factor. And I go ahead and I will write that here. And I know that that's what comes out. And now most of you, I think, can do that. What you can't do is you don't understand what's left inside. Well, folks, it's right here. A 5, a 3, and a 1. Look at that. So we can put the 5 here, because 5 times 10 is 50. Look at that. X squared plus we have 3x. 10 times 3x is 30x minus, and the last one is a 1. There's no variable. 10 times 1 is going to negative 1, and there you go. Look how simple. Look how simple that is. Okay, we're going to try one more. Let's see, maybe even you can do it yourself. All right, we're going to write down 18x cubed plus 24x squared plus 36x. And I'm going to say factor that. And you're going to look first to see if there is a common variable. And you look and say, oh, look at that. There is an x in every single one of those terms. Now, which one should I take out? Obviously, you're going to think either the x cubed or the x. Well, you always take out the smallest exponent. Now, why is that? Because that's what will fit into each one of these. All right? You can just memorize that the smallest exponent is what you take out, or I'll show you why. Because this x cubed actually has 1, 2, 3 x's is multiplying. X squared is multiplying 2 x's, and x is just x to the 1. Now, if I pick the larger one, 3 of them, well, I don't have 3 here, and I don't have 3 here. It's not common. But the smallest exponent is common in each one. So I take out, oops, sorry, I'm just learning how to do this. Take out the smallest exponent. And now I go ahead and look at the coefficients. Well, I'm clueless. We'll do the ladder method. 18, 24, 36. Make your L for your ladder. Well, let's see. I could use a lot of different numbers, but I make believe I don't know again. And I'm just going to use the 2. All right. You could have used 3 if you wanted. That would have been fine too. But I'm going to use the 2. And I'm going to say this is 9. This is 12. And this is now 18. And now I said, oh, look, these are even. 9 is not even. It won't do. Or maybe I can use 9. 9 to 18. 9 doesn't go into 12. All right, let's go up to my next number, 3. 3, 3. Yep, 3 goes into all of them. So here we go. Put the 3 out here. 3 into 9 is 3. 3 into 12 is 4. And 3 into 18 is 6. 3, 4, and 6. Well, these 2 are even. That's not. No, 3 goes into 6, but not into 4. That's it. We're done. All right, go over here. Take the 2 and the 3. 2 times 3. It's not 23, it's not 5. You're multiplying. 2 times 3, 6 is your greatest common factor. Look at that. Bring out the 6 in front of the x. And what do I put in here now? Oh, I don't know. Sure you do. You got a 3 right here. 3. 3 times 6 is 18. But now I need an x. I only have x to the 1. I need x cubed. Now remember, when you multiply variables, you add the exponents. All right, so I know I need 2 more. 2 and 1 make 3. Plus, I can go 6 into 24 is 4, but I know it's right here, 4. And I have x to the 1, I need x2, so I need 1 more x. Plus, I have a 6. Let's see, 6 times 6 is 36, looking good. Oh, x, if I write an x here, folks, then I'm going to have x times x is x squared. That's no good. I'm just going to leave it at that way. So what I'm going to do, actually, and just to make it a little nicer for you, I'm going to go ahead and do that. And this is your answer. This is a 6. Ladder method is really nifty. All right, now going on to the next. We said the very first thing you look for as you're factoring is if there's a greatest common factor. The second thing you always look for is to see how many terms you're looking at. If you only have 2 terms, like this x squared minus the 9, if you have perfect squares and they're taking the difference, meaning they are subtraction, difference means subtract. Take the difference. Then you have what's called the difference of perfect squares. And that is very easy to factor. What you do is you take the square root here. X times x is always going to be x squared. And the square root of 9, what 2 numbers multiply the same to give you 9? 3 times 3. You put the x there, you put the 3 on the back end, and 1 is positive, 1 is negative. Or you could have written this negative first and then the positive second. Why? Because the middle term will cancel. Now, the one thing I don't think I've showed you is, I'm going to write it over here so you can see, x minus 3. If you actually go ahead and multiply using either the distributive property or FOIL, you're going to end up getting x squared. You're going to end up getting a plus 3x, a minus 3x, and a negative 9. The middle term will be the same. One will be a positive, one will be a negative, because everything is the same except for the signs. So this will end up to be 0x, which is 0. So you're going to get x squared minus 9. Now, I know you're going to laugh, but I always do this. I always know what my middle term is going to be when I do 2 smiley faces. Inner, outer. My 2 smileys. Positive 3 times x and then negative 3 times x. That's always going to be my middle term. My 2 smiley faces. All right, so we come over here basically. Let's get back to the factoring. We go over here and we see that we have two perfect squares. There's a difference, so therefore we can write the square root of the first term, square root of the second term, positive, negative, or negative positive. Let's try the second one. All right, we have 4 now. Two terms, so it's only a possibility, remember, that it's a perfect square. We have to look. 4 is 2 times 2, x squared is x times x. 25 is 5 times 5, y squared is y times y. So we're good. And there's a difference. So we can say that this is going to be factored into 2x, take the square roots, 5y, and this is going to be exactly the same. One's positive, one's negative, you're done. That's only, again, if you have two terms, both of them perfect squares, and you're taking the difference. All right, now you think you've got it, right? I'm going to give you one to do. This is an easy one. Let's see how you do it. I'm going to go 9x squared. We'll make it simple, okay? Plus 4. Try to factor that. See how you do. You can pause the video, do it, and come on back. All right, the answer is, well, some of you may have written 3x plus 2, 3x minus 2, and that would be wrong. Now, why is it incorrect? Because you have a positive. It's not a difference. So therefore, the answer is not factorable, or you're going to say and be asked, all right, it's prime. You know what prime numbers mean. Only 1 times the number itself, no factors. You cannot factor that. It's a prime. That's it, not factorable. All right, one other thing, I'm going to show you how to use the graphing calculator to go ahead and determine squares. All right, the way you do that is you go to y equals, and you're going to type in x squared. So you want all the y's that equal x squared. Now, we're not going to graph it. We don't want to graph it. So what we want to do is we want to get a table of all the squares. We want to get a table of squares. So therefore, we're going to look for the word table. You're going to depress second and graph, and that is table. And once you hit the second and the graph, which is the table, this is what it's going to look like. Now notice the left column, you're going to have here 1, 2, 3, 4, 5, 6. That means 1 squared is going to be where the y is, 1. 2, if you have that as the x and you square it, that's going to be 4. 3 squared is going to be 9, 4 squared 16, and so on. And you can keep scrolling all the way down to the next screen, and you'll get 8, 9, 10, and it'll keep going. Now, if you look at the y, you can see that you have, say, 25. So the square root of 25, you look to the x, that would be 5. 5 times 5 is 25. So this is your table of squares. Now, if you had gone into the y equals and put y equals x cubed, you would have gotten the table of all cube values. And you could have found out what the cube root is of any number. So this is very helpful, though, when you're looking at factoring and you're not sure of your squares. And later on, when we get to radicals, this is really good also to use this. All right, still factoring. The very first thing we did was look for the greatest common factor. The second thing we looked for to see if it's 2 terms, difference of perfect squares. The next thing we're going to look for, the third thing, is always going to be if it's 4 terms, and it's grouping. Now the textbook that you have factors mainly with grouping. So I'm not going to discuss the grouping. It's in the textbook and it's all in the problems, the video problems that you're going to see in this module. So that's taken care of. The next thing we're going to talk about, and the last thing, is going to be trinomials. Trinomials, there we go. Now, you can have something where it has a trinomial of just a 1 in front of the x squared. I think you all know how to do this already from high school. Your two factors have to multiply to get 12 and add to get 7. And you're always going to have the binomial, an x here because it's x squared. That's easy enough. What are the factors of 12? 1, 2, 3, 4. Let's see. 1 times 12, 2 times 6, 3 times 4. 4, I already have 4. All right, so let's see. The signs are the same. If you have the same sign, you're going to add. If you have different signs, you're going to subtract to get the middle term. All right, so let's see. We have the same sign, a positive and a positive. Well, we can see that also. Remember, I'm sure you know this too. You take the first sign, signs are easy, and you always put it in the first. The second sign, think of second. Second means 2, so you have to multiply the 2 together. Positive times positive is positive. That's how you get the signs. You don't even have to start working and figuring it out. The first one comes down, the second one you multiply the 2 signs. All right, so we're multiplying to get 12, we're adding to get 7. I got that right here. Always write the larger number first. Always, always, always. Larger number first. Ignore the sign. I don't care if it's a negative or positive, it's the absolute value. All right. The 4 is larger than the 3. You write the 4 first and then the 3, and that's your answer. Now, the way to check it, watch, like FOIL, first and last, first. First in this parentheses is x times x is x squared. The last in each parentheses is 4 times 3 is 12. Middle term, remember my little smiley face, little smile, big smile. We got 4x, and we have 3x equals 7x. Is that right? Yep, you got it good. There you go. That's your simple trinomial with 1 as the leading coefficient in front of the x squared. We're going now to discuss the last factoring procedure that there is. We look at this problem and we're going to factor this trinomial, 3 terms. Now the leading coefficient in front of that x squared is not a 1. That is a 2, and anything that's greater than 1, you're going to treat this a little differently. Now the last problem we did was a simple trinomial, leading coefficient was 1. I think you all could get that. So we're going to change this to be exactly what we just did before. Now, I know in the textbook it talks about grouping. I know also you've all learned different ways to do this, one with the X and what's called an AC, DC, all these different methods. Do what is good for you. I'm just trying to show this method for especially those who are having a little difficulty with factoring. Also, this could be another way that you could check your work. So watch and see how it goes. It's called divide and slide, and you don't do that until the very, very end. We want a 1 instead of that 2. So I'm going to take that 2 and I'm going to use it and multiply it here times the 5. And it's going to go away. Now, the minute I go to do that, remember, everything has to go in pairs and twos to keep everything in balance in algebra. You think of a scale. If you do something to one part of the scale, it's not in balance. You have to do the same thing to the other part of the scale. So once I go to multiply that, now I have 10, I know that I have to also come down here. Since I multiplied by 2, you got it. Somewhere I have to divide by 2. Divide. See the divide? And that's later. Just make your line somehow know that later you're going to divide. And now here we go. Just work your problem. It's your regular trinomial, just the way we did in the last problem. So you're going to go here, make your binomials, parentheses. You have an x here. You got an x here to get the x squared. We're going to multiply to get 10. And we're going to add to get 3. Well, let's see what the signs are first. Bring down your first sign. Remember, second means 2, so you have to multiply the 2 together. A negative times a negative is going to give me a positive. All right, so we need to multiply to get 10. And we need to, well, these are going to be different, so we're going to subtract to get what? 3. So I'm going to take the 10 and I'm going to write all my factors. 1, 2, 2 times, I'm sorry, 1 times 10, 2 times 5. Oh, wait, 2 and 5. I see the difference is 3 right there when I subtract them. Good. Difference is 3. Now, you don't have to be concerned with the signs. Why? Because you write the larger number, 5. That goes first, and then the 2. And look at it. Negative 5x and a positive 2 is a negative 3. Good. Now, some of you may forget and you may stop here. You cannot stop here. First of all, x times x is x squared. You forgot the 2. All right? You can't stop until you do the divide and slide. And that's why I make sure that I put this down here so I will not forget it. All right? So divide and slide. You go to the numbers only and you divide that 2. You multiplied it here, you got to divide it back, folks. Only the numbers. Now, if it doesn't divide evenly, what do we care? Just slide it on over. So this doesn't divide evenly into the 5, slide it over. 2x minus 5. This divides nicely, it's a 1. So that's x plus 1, and that's your answer. All right, I'm going to go through it quickly one more time so you'll understand how to do it. Try it on some of them. Don't be afraid to try it. Nobody's looking over your shoulder. All right, we want to get rid of the 2. So we multiply it by to the 5, put it here, and we make a line to know, okay, later on, I've got to divide that back. That's all. Now work your problem normally like you always do. It's easy. Now at the very end, divide it back. Just take the number that's there and divide it back. And if it doesn't divide evenly, just slide it over to the front. Stay within the same parentheses. All right, we're going to try one more just to show you. Okay, we have one more problem. Here we go. Trinomial. And I don't see any greatest common factor at all. So we're going to work the problem. We're going to simplify it to be a single trinomial with a 1 in front. We want that x squared like that. So we want a 1. So we're going to take this 3 to get rid of it. We're going to multiply it by the 2, and we're going to get the 6. And I'm not going to forget that I have to divide back by the 3. If you multiplied by it, later on you got to redo that, get rid of it. So you do the opposite action. You're going to divide back by the 3. Okay, now work your problem the way you always do. All right, you make your binomial parentheses. We have an x squared, so it's xx. First sign is a subtraction. Second sign is negative times positive is a negative. Oh, look, I got 2 negatives, so I know I'm going to add. So I'm looking to get 6 to multiply, and I'm going to add to get 7. I can ignore the signs. I don't care about the signs. All right. I know the signs are the same, so that's why I wrote add, because same signs. All right, okay, so multiply to get 6. So I have 1 times 6. Oh, wait a minute, right there, I got it. 1 and 6, I add them, it's 7. Look at that. Write the larger number first. That's so important because of the signs. 6 and 1. All right, let's see now. Middle term is a negative 6x and a negative 1x. All right, good, we're good. And then looks good. Now, that was easy. We did one step. Great. Now we have to divide back by 3. Remember, it's called divide and slide. If you can't divide, slide it, but stay within the same parentheses. All right, so the 3 goes over here and the 3 goes over here. 3 into 6 is 2. So I have x minus 2. 3 does not divide into the 1, so I'm going to slide it up there. 3x minus 1. And that is your answer. And you check it. You can do FOIL or distributive, but the first times the first is 3x squared. The last in each parentheses is negative 2 times a negative 1 is going to be a positive 2. My middle term, my little smile, and my big smile. Look at that. Negative 2 times 3 is negative 6x. And an x times negative 1 is a negative x. And this is going to always add. So we have negative 7x plus 2. And it checks. So this is your answer. It really is easy. You do 1 or 2 of them and you're going to see how simple it is. All right, the last tip I'm going to show you is that you can show and find out what all the factors of a number are. If we have something like x squared plus 25x plus 24, and we have to find out what all the factors of 24 is, you go to your graphing calculator, you go again to the y equals, and this time you put the number that you're looking to factor here, divide by x. And you're going to hit second and graph to get the table. And it'll be all the table, show you all the factors of 24. All right, you'll see all the factors of 24 in the table. Now you know how to do 24 divided by x. All right, the 24 go over to the side where the division is and the x. All right, and that's very, very helpful to especially get to all the factors of a number. And this is the end of this video.